we're back to our tug of war. So as someone kindly pointed out, when we form a cation, we typically lose an actual energy level. That right there will decrease radius. But beyond that, this is down to tug of war. So in the initial neutral lithium atom, it's 3 on 3. 3 protons pulling on 3 electrons. When we make a lithium 1+ ion, we now have 3 protons pulling on 2 electrons. They can pull them in towards the nucleus more strongly, and the atom shrinks. The atom gets smaller. When we form an anion, fluorine picks up an extra electron. Same thing, it's tug of war. We used to have 9 protons pulling on 9 electrons. Now we have 9 protons pulling on 10 electrons. Those electrons can get further out from the nucleus. They're winning the tug of war in essence because there are more of them. So the entire ion gets larger, it gets fluffier. So if I were to ask you, pick up your periodic table, calcium. Which of these would have a larger atomic radius? A neutral calcium atom or a calcium 2+ ion? Jot them down, circle them with the larger radius. Calcium, neutral calcium atom, or calcium 2+ ion. Circle the one that has the larger atomic radius. Hey, I haven't heard from you in a while. What do you think? So between a neutral calcium atom and a calcium 2+ ion, which one will have the larger atomic radius? Yeah, the neutral calcium atom. Because when we form a cation, we're going to decrease the atomic radius. That seem reasonable? It's really all down to tug of war. And you can think about it in those terms, and I find that those are pretty easy terms to remember it on. Okay, let's erase these as we start to talk a little bit about valence electrons. This is critical because this is what controls what kind of compounds are formed and how things react. Valence electrons are the electrons that will interact with other atoms. They can be lost, gained, or shared. They are the outermost energy level electrons. Okay. When we talk about S and P in main block, these are your S and P electrons. So for sodium, it's got 1 valence electron, which is in 3s. For calcium, how many valence electrons does calcium have? Outer S.
2.
Just 2. It's group 2. So calcium ends with 4s2, so we have 2 valence electrons. Well, in group 1 and 2, number of valence electrons is equal to the group number. That's easy to remember. So if you're group 1, how many valence electrons do you have? Hold up fingers. 1. You're group 2. How many valence electrons do you have? 2. Easy. We like easy. Easy is good. If we move over to the P block, it's the group number -10. And that seems familiar somehow, doesn't it? Where does that seem familiar from? Well, but there was something else that was for P block, group number -10. Well, number of S and P electrons, which is the same as saying valence electrons. We're saying the same thing in a different way. So, if you are a group 15 element, hold up fingers. How many valence electrons do you have? If you're a group 13, how many do you have? If you're a group 17, how many do you have? You all got that. Good. Okay. We're actually going to stop there.